Hi guys! Today we're going to talk about the spread model of COVID-19. Today is April 7th, 2020. There are over 380,000 confirmed cases of COVID-19 in the United States. As we can see in this chart, the number of confirmed cases grows exponentially. At least 270 million people in at least 33 states are being urged to stay at home. Americans have been asked to do what might have been unthinkable only a month ago. Don't go to work, don't go to school, don't leave the house at all unless you have to. However, many of them consider that stay-at-home order is unnecessary and still go out for parties and outdoor activities. Today, we're going to calculate how many days it will take for every American to get infected without social distancing, specific medicine, or vaccine. That is, if we let this virus spread freely, how bad will it be? For convenience, we will assume the US is an enclosed area and that there are no imported cases. Before doing the calculation, we are going to learn a concept, the basic reproduction number. We call it R0, pronounced as R0. As we mentioned in the previous video, R0 is the expected number of cases directly generated by one case. If R0 is more than 1, each existing infection causes more than one new infection. The disease will spread between people and there may be an outbreak or epidemic. Scientific research shows that the R0 of the coronavirus is between 1.4 and 3.8. which can be conservatively valued to around 2. That is, one patient will infect 2 healthy people on average. The median serial interval of the coronavirus is about 4 days. That means 4 days after the first generation gets sick, the second generation shows symptoms. The first patient, called patient 0, is the first generation. This patient infected 2 people. So there are 2 new patients in the second generation. Each of these patients will infect 2 people, which means 4 new patients show up. That means 2 squared patients in the third generation. Each of these patients will infect 2 people, then we get 8 new patients in the fourth generation, which is 2 cubed patients, and so on. In the nth generation, there will be 2 to the exponent n minus 1 new patients. Okay, by the nth generation, how many patients are there in total? As we can see, this is a proportional series, also called a geometric series, which is a series with a constant ratio between successive terms. That is, each successive term can be obtained by multiplying the previous term by a constant. Here, the constant is 2. Then, we use the formula for the sum of geometric series to get the result. The sum is 2 to the exponent n minus 1. I'm not going to prove this formula in this video, but if you'd like to learn more about it, I can post a link in the video description for you to check out. Okay, we have 2 to the exponent n minus 1 patients in total after n generations. Now, what is the population in the United States? Based on data from the United States Census Bureau, the current population of the United States is 330 million. If all Americans will get infected after n generations, that means 2 to the exponent n minus 1 is equal to 330 million. Then we get n is equal to 28.3 generations, and we already know that the interval between each generation is 4 days. That is, 28.3 times 4 equals 113.2 days. According to CDC records, patient 0 in the United States was reported on January 24th. 113 days later, that is May 13th, this coronavirus would affect every American person. Of course, this is a simplified model, and the actual situation will be much more complicated. A high contact rate will contribute to a higher R0 value. But if someone stays at home all the time without contacting anyone else, he or she wouldn't get infected at all. That's why more than half of the states had told their residents to stay at home as much as possible. At the end of this video, I'm going to show you a useful tool, a map. It allows you to search and drill down into communities to view populations most vulnerable for severe outcomes if infected with a COVID-19-like virus, and the socioeconomic factors driving that risk. I will post the link in the video description. That's all for today. If you have any questions, please leave your comments below or email us at question@beat-math.com. We will try to answer your questions in the next video. See you next time.